Good evening, students. I welcome you for the DT-based topic, that is Wams and network topology. The full form for the Wams is Wide Area Monitoring System. The purpose of having this wide area monitoring system is to operate the power system from the remote place. So we know that the power system will be expanding for several hundreds of kilometers. If anything has to be operated, we have to go to the particular place and operate. That will cause an real time issues. So we are sitting in a remote place and we'll be operating the entire power system. So that will be enabled with the help of the wide area monitoring system. And the second topic is network topology. So the connection fashion will be of various categories such as ring main, radial or bus, etc. So that will be studied in this topic.
Hello guys, so today we'll be seeing about wide area monitoring system and network topology in power system. Since the future is focusing on the smart grids and large geographical area of power grids, so we need to improve our monitoring systems. And in a previous generation, we will be focusing on direct monitoring where the more labor works are needed. So in upcoming modern large geographical area will be utilized for power grids. So in that case, we couldn't able to directly monitor them. So we'll be going for an wide area monitoring system where we remotely access all the power grids. If any fault occurs, we can able to remotely monitor the power grids and shut down it or rectify it if needed. We basically know about the what is WAMS and network topology. Now we can see about what is the definition and purpose of the WAMS. So in this modern power grid, what we'll be focusing is the status of the power grid to monitor them. So we'll be focusing on the synchronized phasor measurement to provide a real-time visibility into power grids to know about the status of the large geographical area. And the main role of this WAMS in modern power system is providing a dynamic grid management, renewable integration, and adaptive control. And we all know that about SCADA and PMUS, which have already been introduced. So we will be using WAMS along with this integration of the SCADA and PMUs for further more monitoring and controlling system. So now let's see about the need for WAMS system. So why we need WAMS system is growing complexity of power grids and real-time monitoring of large areas, along with the prevention of blackouts and cascading failures, since the future generation is focused on large geographical area of power grids.
So this wide area measurement system will prevent us from getting into blackouts. We all know what is a blackout. Blackout means the power outage for a very large area for a very long time. So that will create more number of issues that can be easily avoided by this wide area measurement or wide area monitoring system.
Now let's see about the key components of Wams. Phasor measurement units, high speed and measuring voltage, current and phasors with GPS time, synchronization to enable precise real-time systems. Phasor data concentrators, aggregates that collectors, time aligns and PMU data before transmissions. Communication infrastructure, high band, low latency networks ensuring timely and reliable data transfers. Control centers, operators, hubs equipped with advanced visualization and analytics tools interrupt the WAMS data and make informed control decisions. Benefits of WAMS: enhanced situational awareness, real-time insights across the large grid regions improves operators' understanding and response capability, real-time system ability, continuous tracking of voltage, frequency and phase angle derivations, improved grid reliability and security, increased robustness against faults and attacks through better systems, better response to disturbance, rapid identifications of events enables quicker coherative actions to minimize impact. Challenges in WAM implementation: data management and synchronization, handling large volumes of time stamped data requires sophisticated algorithms to ensure alignment and meaningful analysis, communication delay and reliability, maintaining low latency and reliances in data links is critical to prevent stale or lost data affecting decision making, cyber security and privacy concerns. Protecting WAM's infrastructures from cyber threats is essential to safeguard grid operation and sensitive data. Cost deployment, a high initial investment in hardware, communication networks and system integration can deter wider space adoption.
So the next topic of our slide is network topology. So I like to hear the actual definition of network topology from Miss Monica.
So, the network topology will describe the physical and logical arrangement of the components and the connection in the power system. So, it is essential to build the topologies in order to there will be like many fault occurs in the system. So, it will affect the topologies will affect the reliability of the system. So, it is essential to have the system.
So in this slide, they have mentioned as radial, ring, and mesh, and some kind of hangout or hybrid. So what are all those type of topology will try to tell us why those various types of topology are important.
So these are the types of network topologies: mesh, ring, line, tree, and fully connected systems. So now let us see about the radial topology. So the radial topology will be in the form of tree structure. In the radial topology, each customer or the load is connected to a single path from the power source. So it has an advantage of simple design, and it is easy to implement. So next one is the ring topology. So in the ring topology, each node is connected to the exactly to the other two nodes, and it will be in the form of closed loop. So it will be having the advantages of better reliability than the radial topology. See, the next one is the mesh topology. So in the mesh topology, every node is connected to every node. So it will be common in the transmission network. So it will have a very high fault tolerance. The next one is the hybrid topology. The hybrid topology refers to the combination of two or more topologies like radial and mesh topologies. And it will be having the advantages of customizable based on the system nodes.
So hi everyone, I'm going to talk about impact of topology on power system performance. The first important point is it improves the reliability and fault tolerance of every system. It is the different types of system improves the reliability and fault tolerance. The second point is maintenance and operation flexibility. By connecting this in different types of systems, we can improve the it is easier to maintain the each and every nodes very easily. Then the power quality and load distribution. The third point is power quality and load distribution. As the different nodes are connected with different structure, the optimal arrangements minimizes the loss and voltage fluctuation. So it improves the power quality overall. The last point is system protection and coordination. Topology influences protection devices and placement and coordination schemes to ensure rapid selective fault cleaning.
So we came to the end of the DT presentation. So we discussed about the wide area monitoring system and types of network topologies with some interesting activities. So what the final thing is, network topology will tells us what are all the various types of connections available for connecting the entire power system, and wide area network will tells us how the power system can be monitored and also controlled from the remote place. Thank you for your patient listening. We'll be discussing another interesting topic in the upcoming video. Thank you.